Okay, so fourth grade, our project is going to be called the Newton's Disk. Now, the Newton's Disk is a well-known physics experiment where you actually take the colors and you turn them back into white light. So I'm going to pan you down here and show you how to make the Newton's Disk. For this project, you need a piece of heavy white paper. You can even use a piece of cardboard and just glue some white paper on top. You'll need a ruler. You'll need something round to trace. I have a candle here. You'll need a pair of scissors, a pencil or a pen, and you'll need some crayons. The colors that you want to use for the experiment are red, orange, yellow, green, blue, and violet. So to get started, take your tracer, and it can be any size that you find, and I'm gonna make 2 of them here in case if I make a mistake. So I'm gonna trace my circle there, and I'm gonna put one right here. So you can see that. And now what I wanna do is I wanna divide up my circles into 6 even sections. So to do that, I'm gonna first measure how big my circle is, and my circle is 4 inches. So I know that 2 inches is gonna be where the center is. So I'm gonna do it from north to south, and then west to east, and put a little X right there. And that's where the center of my circle is. Do you see that little mark right there? So I'm going to divide a line down the middle. Just like that. And now you want to put an X across the paper. That will give you 6 sections, 1 for each color. Okay? So I'm gonna start with my red. And don't color too hard. I'm using watercolor paper. And notice I went off my line. That's totally fine because I'm gonna cut it out. So here's my orange. Here's my yellow. Moving to the green. If you don't have crayons, you can try this with marker. I'm gonna now move to my blue. And finally the violet. Okay. Now I'm going to take my scissors and I'm going to cut this out. Try to follow the edge of that circle really neatly because we're going to turn this into a spinner. So you want the circle to be nice and even so it spins evenly and it doesn't wobble on you. Okay. Alright, so boys and girls, now that I have my wheel colored and cut out, I'm going to take a thumbtack and right in the middle where all the colors meet, I'm just going to poke a hole. Just like that. And I'm going to take a toothpick and put the toothpick through to create a little, whoop, can you see that? Do you see that little tip right there? That's what the wheel is going to spin on. Now, to hold that together, you can put just a little bit of glue and let that dry. But for our experiment, I'm going to put some hot glue on it. Okay, so I put a little bit of hot glue on, and I'm just going to hold it until it dries. And one thing that I notice as I'm doing this is do not put the toothpick all the way through the hole because you'll make the hole too big. You just want the toothpick to have just the tip going through. And you want this to be nice and even as that glue dries. And like I said, if you're using the Elmer's glue, you might want to just stick this into something so it has some time to set up. But I think that that's done. I can't wait to try this out. Alright, so boys and girls, now it's time to put our Newton's disc to the test. We're going to spin the disc, and you can see in the picture here that the colors are all sectioned off, and as the disc gains speed, it's going to appear to look white. Now what's happening is, as we're spinning the wheel, the colors are moving so fast that our eye cannot tell which color is which. Alright, so here's the first disc that I made. And what I did also, boys and girls, I didn't do this on camera, but I just cut off part of the toothpick. That way the top isn't heavier than the bottom. So here's my first one. The second one I created has some more color in it. I had 8 sections of color, so I added some tertiary colors in there. And my third Newton disc is one that I colored with marker, and it's quite dark. So we're gonna see which one of these is the best one to use for the science experiment. So I'm gonna pan you down, and let's see how this works. All right, let's start with the first one that I made, which has the 6 colors. And I colored very lightly here. So we'll see if it works. So I'm gonna spin it, and hopefully we're gonna see something like we saw it in the photo. All right, here we go. Wow, look at that, boys and girls. Against the white table, the colors vanish, and it appears white. I didn't expect it to look that good. Let's try this again. That's so cool. Let's try it with disc number 2. Now notice I colored a bit darker, and I added some tertiary colors. So let's give this one a whirl. Wow, that too worked pretty well. That's amazing. Now let's try the darkest of the 3. Let's see how this one works. That is amazing. If you look at it, it's not perfect, but look at it. The colors seem to vanish. Now what's happening is a really cool phenomenon called the persistence of vision. It was such an important discovery because it proves that light is not colorless. This experiment was the final proof that white light is made up of all the colors of the spectrum. And by doing this experiment today, you can clearly see how we can reverse the rainbow. Give the Newton disc a try, make several of them, and see if you can get them to all work. I hope you enjoyed this lesson. If you master the project, you can try to go on to one of the other grade levels and see what they're doing. I'd love to see your Newton disc. You can have mom or dad email me at pricet@pearlriver.org, and I can post your picture online. And also, please make sure you're filling out the Google form, which is located on the homepage of my website. I'll talk to you next week when we will have more art online. Have a great day.